Bismillahirrahmanirrahim. Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. In our previous video, we have seen similarity of triangle, that is the definition of similar triangles. And now, in this video, let us see the proof of basic proportionality theorem, or which is also called as Thales theorem. What is the statement of the BPT? The statement of the BPT is, if a line is drawn parallel to one side of a triangle, divide the other two sides in the same ratio. Dividing the two sides in the same ratio means dividing the two sides in proportionately. Okay. Now first half of the statement is called data, and the next half of the statement is called to prove that. Now the data is triangle ABC. Okay. You have to draw the figure, then D is drawn parallel to BC. So in triangle ABC, D is parallel to BC. This is data. Okay. Now the next half is divide the other two sides in the same ratio. The other two sides are AB and AC. D is dividing AB in two parts, AD and DB. E is dividing AC in the two parts, AE and EC. So here to prove that AD upon BB is equal to AE upon EC. This is what to be proved. Now construction. To write the proof of the theorem, some construction is to be done in the figure. So in this particular theorem, what construction is done is join B to E and C to D. Join B and CD. Okay. And draw EL perpendicular on AB and DM perpendicular on AC. So draw EL and perpendicular on AB and DM perpendicular on EC. This is the construction. Now let us write the proof. Let us see the proof. Proof, we know that area of triangle is half BH. 1 upon 2 into base into height. Now write area of triangle ADE upon area of triangle BDE. So ADE is upper part and BDE is lower left part. Okay, this you have to remember. Triangle, area of triangle AD upon area of triangle BD is equal to, let us apply formula here, 1 upon 2 into the base is AD into the altitude is EL upon 1 upon 2 into the base for BD is DB and again the altitude is EL. Now how to remember this? I give some sort of what you call hints here to remember what to write. Okay. Now what is here? AD. So write half into AD into what is the first altitude? EL. So half into AD into EL divided by half into what is here in the numerator, denominator. This is DB. Write DB into again the same altitude EL you have to write. Okay. Now half will be going to get cancelled. EL will also be cancelling. AD upon DB will be remaining. Write AD upon DB and call it as equation number 1. Now similarly write once again in the numerator the same upper part of the triangle ABC, that is triangle ADE, area of triangle ADE upon, in the denominator this time you are going to write the lower part which is towards right side, that is triangle CDE. So area of triangle CDE is equal to, once again the point to be remembered how to write, that hint I am going to give you here is write half, then you come here, what you wrote to prove that. Okay, AE, then RHS, AE, write AE. Okay, into next altitude or the perpendicular drawn on AC, that is DM. Okay, divided by 1 upon 2, what is denominator here in right hand side? EC, write EC, multiplied by again same altitude DM. Okay, this is very easy to remember and write the next part of the ratio of area of triangle ADE upon area of triangle BDE. Similarly, area of triangle ADE upon area of triangle CDE. So here also half got cancelled, and at the same time DM got cancelled. AE upon EC will be remaining. Call this as equation number 2. Now area of triangle BDE is equal to area of triangle CDE. Now in 9th standard you have studied the triangles drawn on the same base and between two parallels are equal in area. Not only triangles, you have studied about the parallelograms also. The two parallelograms which are drawn between two parallels and are on the same base are equal in area. So this sort of theorem what we have studied in 9th standard is to be applied here. Area of triangle BDE is equal to area of triangle CDE, because BDE CDE has the same base DE and they are between two parallels DE and BC. So right here the reason triangles on the same base and between two parallels are equal in area. So from 1 and 2 BDE and CDE are same. Therefore from 1 and 2 we prove that AD upon DB is equal to AE upon EC. QED, that is Cordemann's demonstration. This is how the basic proportionality theorem or Thales theorem is proved, and how we write the proof of the theorem. So dear students, let us see the converse of basic proportionality theorem or converse of Thales theorem. What is the statement of the converse of Thales theorem? It is, if a line divides any two sides of a triangle in the same ratio, then that line must be parallel to the third side of the same triangle. This is the statement of the converse theorem. I have written only just here. See this triangle ABC. In this triangle one line is drawn, that is DE. This line dividing AB and AC into 4 parts, AD, DB, AE and EC. Now in this, if this line is dividing the two sides in the same ratio, that is AD upon DB is equal to AE upon EC, then this particular line must be parallel to the third side BC of triangle ABC. So in triangle ABC, if AD upon DB is equal to AE upon EC, then obviously that line DE must be parallel to the third side BC of triangle ABC. So this is the converse of Thales theorem. Now dear students, in the next videos let us solve few of the problems based on Thales theorem and the converse of Thales theorem. Thank you.